Hi and welcome to another of BYJU'S live session. Today we are going to talk about mechanics, that's basically kinematics and dynamics, right? Now, I hope that your journey with physics uh, it has just started and it's been pleasant. You must have done the chapter of units and dimensions and vectors and mathematical tools. These are the basic, and I must say the very light chapters of physics. Now you're entering the realm of kinematics. Okay, this is the place where you realize that now from now on things are going to be logical. It's not going to be how it used to be in 10th standard, where I used to I just have to remember the definitions, I just have to mug up a few things here and there, and I just remember the units, you just have to reproduce it in your examination. That's not the case now, right? Now things are going to be logical. If something is told to you, is it's not just that that you have learned that is enough. Okay, it's not just that you have understood the theories enough. How well are you able to apply it is what matters, right? And the whole preparation for JEE is about application. Are you able to apply that idea? Are you able to apply that idea? Are you able to uh, solve a problem given the knowledge that you have? Because there might be two individuals, one might know the theory and other might also know the theory, and when they sit to solve a problem, one might be able to solve the problem, one might not be able to solve the problem, right? And that is because one has more practice with the thing and one is able to apply that knowledge, right? Now let me talk about kinematics. Okay, uh, so basically in mechanics is divided into kinematics and dynamics. So what happens in kinematics, you study how is the motion happening, okay, and in dynamics you study why is the motion happening. So in kinematics, what you don't ask the question why is it moving the way it is moving. You just say that okay, this is the pattern in which it is moving. Now given this conditions in the first place, where will it be after this many seconds? Okay, what will the future be? The whole purpose of physics in a sense is to predict the future, what is going to happen in the future. Okay, and with deterministic laws in the classical realm we are studying. Now you study kinematics by studying about average quantities. Okay, you study about speed, and there's like an average speed, there's an instantaneous speed. You study about distance, displacement, you study the difference between distance and displacement. Those are not very difficult things. Then you study about velocity, average and instantaneous velocity, right? And you study about acceleration, average acceleration, instantaneous acceleration. Now before I go into like how to find these averages and what are the things to keep in mind, I would like to draw your attention towards the difference between velocity and acceleration. This is where students in the initial stages are very confused, I find. What is the difference between velocity and acceleration? So okay, the teacher told me the definition when I was of your age, that you know the velocity is the rate of change of the displacement and acceleration is the rate of change of the velocity. Cool, but I didn't get it. Okay, so I had to like find some analogy in my mind to fit those two things in. Now, so the way it works is, the way my analogy is, I'm going to tell you the same thing. In case you're confused, it might help you. So speed is the rate at which something is moving, right? That's what velocity is the rate at which something is moving. Now acceleration is something that wants to change the velocity. That's the way I see it. Acceleration wants to change the velocity, but that's not enough. Acceleration wants to change the velocity, and it wants to change the velocity in its own direction. Okay, what does that mean? It means that, let's say this is the direction of velocity, the something is moving in that direction, that's the direction of velocity. Okay, and if let's say it is also accelerating in the same direction, so now acceleration and velocity are in the same direction, right? It means that the velocity will keep on increasing because the acceleration sort of is coherent with the velocity. So I like to say acceleration is something that attracts velocity. So because acceleration and velocity are already in the same direction, the velocity will keep on increasing, or the acceleration will keep on attracting uh, in a metaphorical sense. Okay, it's just an analogy. Now if it so happened that the velocity was in this direction and the acceleration was in this direction, now what will happen? Now acceleration wants to pull the velocity or the object in that direction, the acceleration wants to increase the velocity in that direction, but the velocity is already in this direction. So what will happen? So if the acceleration cannot increase it in this direction, it will decrease it in this direction. So what will happen? This thing is moving, and the acceleration is in that direction, this thing will slowly slow down, right? It will keep on slowing down, it will reach a velocity of 0, then it will flip in the direction of acceleration and it will keep on moving in the direction of acceleration. So if the velocity is already in the direction of acceleration, it will keep on increasing. It was 2 meters per second, then after some time it will be 6 meters per second, after some time it will be some x meter per second. But if the velocity is in opposite direction to acceleration, then what happens? Velocity slows down, it becomes 0, then it starts moving in the direction of acceleration and it keeps on increasing. Okay, that's the case with gravity as well, right? That's the reason why when I throw something up, right, it comes down, because see, acceleration due to gravity is always in the downward direction, and when I throw something up, I'm giving a velocity in the upward direction. So now velocity is in the upward direction because this thing is moving in the upward direction. That is also an important point. What is the direction of velocity? The direction in which the thing is moving right now. That's the direction of instantaneous velocity. So it is moving in the upward direction, so the velocity is in the upward direction, but the acceleration is in the downward direction. It means that the velocity and acceleration are not in agreement with each other, right? What does that mean? It means that this acceleration wants to bring this thing in its own direction. So what will happen? The velocity will slow down, it will decrease down. So the object will slow down, the velocity will decrease, it will become 0 at some point, and then it will start increasing. That's what happens when I throw something up. It goes up, and then the velocity becomes 0 and it comes down, right? So that's the idea of velocity and acceleration. One just idea I just wanted to give you. Now I want to talk about average quantities. Now you are given these questions where you have to find average speed, average velocity. So the formula are very simple, right? There's only one formula for average speed. Average speed is equal to total distance by total time. Average velocity is equal to total displacement by total time. Now they give you this all kind of complicated question in which there's a problem, and in which there's an object which goes to point A, from point A to point B with this much speed in this much time with this much distance, and point B to C in some other this thing. So I'm sorry, it covers a distance from A to, let's say, D, in A to B with different kind of variables, B to C with different kind of variables, C to D with different kind of variables. So it becomes difficult. Now how would I find the average speed? So the solution for that is that don't worry about anything. Remember the formula. Average speed is total distance by total time. Find out the total distance. So that for that you have to find the total distance in A to B, distance in A to B, then distance in B to C, the distance in C to D. Then you add all the distances, you get the total distance, and then you find the time from A to B, B to C, C to D. That gives you the total time. You divide both the things and you get the average speed. And the same thing you do with velocity, right? And if when there's a case of acceleration, then average acceleration is final velocity minus initial velocity by time, right? So you have to find the final velocity of the final point minus initial velocity divided by time. Okay. Sorry. Now, in kinematics, we have these three equations, right? V is equal to u plus at, s is equal to ut plus half at square, and v square equals to u square plus 2s. Now, there are certain things we need to understand about these equations, okay? It's not like ki kahin par bhi laga diya, kahin par bhi use, you can't do that, okay? There are certain specific places where you can use these equations. You can't just be like, anywhere I feel like I can use this equation wherever I see motion. You can't do that. So what are the cases in which you can use them? The first thing you have to understand while applying these equations is that they're valid only when the acceleration is constant, okay? If there's an object which is moving such that the acceleration is constant, I can apply these equations of motion. These equations of motion which was given by Galileo, okay? Now, that's the first thing. So, because you see v is equal to u plus at, a is a fixed number which is going to be put there, right? Now, another thing, these equations are always applied between two moments, okay? You have to, before, so someone gives me a problem, you have to solve it, you feel like I can apply v is equal to u plus at. The first thing you should do, and this you should make it a habit by practice, that first you identify the two moments between which you are going to apply this equation, okay? The initial moment and the final moment. Every time you apply an equation, there's an initial moment and final moment, and between the initial and final moment, the acceleration must be a fixed number, okay? And for example, v is equal to u plus at, you have u is the speed of the initial point, right? T is the time traveled from this moment to that moment, the distance, the gap between moment 1 to moment 2, or initial moment to final moment, okay? Acceleration is a fixed thing. V is the final velocity, the velocity when you reach the final moment, right? The same thing you do with s is equal to ut plus half at square, and v square is equal to u square plus 2as, right? So you have to identify two moments and you have to apply these equations between those two moments. If you keep this in mind, when complex situations come, you would not mess it up, okay? Another thing in kinematics to take care of while solving problems is to have a very clear idea of where your origin is, okay? Before solving a problem, before starting to solve a problem, you have to define where my origin is, okay? And what is my positive side, what is my negative side. You start studying kinematics with linear motion, like one dimensional kinematics. In that you just have a origin, then you have a positive side and negative side. That is very important. Without that, you would not know whether your velocity is in this direction or that direction, because a thing can, if you just say that it is 5 meters per second, it could be moving this way or that way. You have to specify that. So every time when you solve a problem of kinematics, you be very clear, this is my origin, this is my positive side, this is my negative side, number one. Number two, what are the two moments between which I am going to use these equations, okay? And that's how you do things. Now, see, the major aspect here is that the theory is not too much, it's just these equations. And what you're supposed to get through this is just that the more practice you do, the more your applying prowess will increase, okay? That's the key thing. Anybody can teach you the theory, and anybody would know the theory. It's not a big deal. It's just that you solve more and more problems, you get internalized, you get more clear about how to apply in what situation, what should come to your mind, and everything becomes like the pieces come together. Now another thing is when you have like questions where there's more than one object which is moving, right? In that case, what I do is I use this modified form of equations of motion, where you have v is equal to u plus at. Instead of v is equal to u plus at, you have v is equal to u plus a times of t final minus t initial, and s is equal to ut plus half at square becomes x final minus x initial is equal to u times t final minus t initial plus half times a times of t final minus t initial whole square. You get the gist, right? Why do I do that? It's because, see, there's a question where there's a balloon which is rising up, then you throw one stone from the balloon, right? It is going down, and 2 seconds later you throw another stone from the balloon, and then 3 seconds after having thrown the second stone, what is the gap between the first stone and the second stone? This kind of questions you get. Now the problem here is it becomes very difficult to identify which is my initial moment and which is my final moment, okay? Now if you can do that, then you don't have to use this modified form. But you can't do that, then I would suggest to do this modified form, in which the moment you drop your first stone, that is your t is equal to 0, and from there the clock has started running, okay? And then your second stone maybe was dropped at t is equal to 2. Now this is the clock, okay? This is not a gap. T is equal to 2 seconds, or t is equal to 2 o'clock, you can say. And then the thing is asking that after the second stone was dropped, 3 seconds after the second stone was dropped, that is t is equal to 5, what is the position of these two is what they are asking. So if you do it this way, the moments will be very clear, okay? If you try to solve a problem, you'll get what I'm saying. Now I think that is about kinematics. There's nothing extraordinary I can tell you in theory. There's actually nothing there in theory. They are just these three equations and careful application of these equations. Now if I talk about dynamics, then dynamics has laws of motion, one of the most crucial things you're going to learn in physics, okay? Now if you don't get laws of motion, make sure you do, because I would like go on to argue that there might not be a single chapter of physics, maybe except optics, where you don't have the application of laws of motion, okay? Newton's laws. Now what are Newton's laws? The first law is very simple. It says that if something is moving, it will keep on moving with the same velocity forever and ever unless a force is applied on it, okay? It means that the natural state of motion of an object is to have a constant velocity, okay? If something is moving with 5 meters per second in this direction, it wants to move with 5 meters per second in that direction. It doesn't want to slow down, it doesn't want to speed up. That's what it wants to do. That's its inertia. It doesn't want to change. That's what it means to have inertia, right? Now when you apply a force on it, that force will change this velocity. That's it, okay? So that's what it says, that an object in rest would stay in the state of rest. Rest means what? Zero velocity, right? Or an object in motion would continue to move in the same direction with the same speed, which means constant velocity, unless an external force is applied on it. Okay, that's the first law. Now, the second law says, what happens if I apply a force? Now, what happens when you apply a force? Of course, when you apply a force, the velocity will change by definition. If the velocity changes, what will happen? You'll have an acceleration, but that's the definition of acceleration, change in velocity by time, right? So the second law quantifies this by saying that the force is proportional to this acceleration, or force is equal to mass times acceleration, right? The more the mass, for the same force you'll have lesser acceleration. Now that's the second law, F is equal to ma. One of the most fundamental laws of classical physics is F equals to ma, right? If you understand F equals to ma and if you are able to apply F equals to ma, they're like a lot. I mean, right from making a bicycle to making a rocket, all this is accomplished just by knowing like proper use of F equals to ma, right? So that's the first principles of physics. And then the third law, for every action there's an equal and opposite reaction. So if I push on this, if I apply a force on this, this is also applying a force back on me, right? They don't cancel each other because they are being applied on different objects. Now, so these are the laws, and it's not very difficult to know the laws and even to understand those laws. Okay, if you contemplate about it, see, sometimes you sit in a class, you might not get it because the lecture is going on, the teacher is telling something, your mind might be wondering, but like you develop a habit of wondering about these things when you're just strolling or you're just sitting having your breakfast. So when you develop this ability to like this actually habit, or I don't know, this thing to wonder about things, ideas become more clear. So even when you wonder, you don't understand, okay, this is what Newton wanted to say and this is how the world works. But does that make you ready to write a JEE exam on mechanics or dynamics? No. It comes down to application. Are you able to apply these things? Are you able to solve problems? Are you able to use this logic? Okay. Now, when you're given a problem of dynamics, then the first thing you have to do is like you have to select a system, right? So you have to be very clear about, this is my system, this is the boundary of my system. This part is not my system, this is what my system is. Step 1 is selecting your system, right? Step 2 is identifying all the forces, drawing free body diagram, like all the forces acting on your system, right? So you draw all the forces. The third step is then you apply in every direction your Newton's law, F is equal to ma. You find the net force, you equate it to mass times the acceleration in that direction. That's it. It sounds so simple. There's nothing more than that. And like, you know, of course you're doing all this in a reference frame. So you have to first choose what is the reference frame, right? The frame in which you're doing physics, because in different frames things look differently. I can go into the details of that, but we don't have time that much for discussing inertial frames and all that. Now, this sounds easy, and I'm sure that if your teacher tells it to you, and when you have solved 3-4 problems, you'd be like, yeah, I got it. What's the big deal? But it is a big deal because it would only come with practice. You know, I give you a problem. How would you know what is the system which I have to choose? How do you know what is my frame of reference? Those things would pop up in your mind only when you have solved enough questions and only when you have done enough deliberate practice. Okay, and sorry, this is true for everyone. Okay, like I think almost everything also. I mean, you take anything. I mean, like anybody who's like learning a new thing, let's say data analysis, and you ask them, this is the problem. Now you know all the theory. You solve this problem. You won't be able to unless you've solved a bunch of problems. Richard Feynman, a very famous physicist, has said that solve all the problems that have ever been solved. Why is he saying that? Because it gives you that element of understanding, right? So that's the whole point of mechanics. There's nothing more to mechanics. There's Newton's laws. Then there are things like constrained motions and all, but they are basically applications of Newton's laws, right? And only with practice you'd learn more and more. I would suggest that you go through our videos. We have like covered these things in much detail and specific scenarios which cannot be covered in a 15-minute session. You go through our practice. We have very intelligently designed these questions which go up the ladder like this, and you learn things and you don't realize that, oh, I've learned this, and at the end of the day you become a pro and you don't realize. And like any teacher in India who's suggesting anybody about JEE, please solve all the problems from HCV, right? they're brilliant questions. So if you solve all the problems, and there are short answer questions which are like very thought provoking. So those questions you should read. Just read those questions. Try to think about those questions, right? So that's what dynamics is about. And please remember that give as much time as possible right now to make your hold on dynamics strong, because this is a chapter. The basics of this chapter is going to be like in almost like anything in physics. Like you go to waves, you go to anything. I mean, like, so even in 12th standard electrostatics, magnetism, if you don't know Newton's laws, you won't be able to do that. So spend a good amount of time, spend like a month and a half, solving just problems every day in this particular chapter. Uh, and if you do that, you'd find that later a lot of things in the later chapters have become much easier for you. Okay. Now another thing which I always suggest to my students is like this is a very simple thing. I don't know, but I just feel that it makes a lot of difference. That make a separate notebook for every chapter, because if you make a separate notebook for kinematics and make a separate notebook for dynamics or mechanics or Newton's law NLM, what happens is like you just write all the theory in that, and then you solve all the problems in that notebook only. Okay, because of I just have all the things which you have done in one place, so that in future if you want to refer to it, you'd have time to do it. I would not suggest this to a person who's like just learning physics on his own, but because you have limited time, you don't want to waste something which you have learned. Okay, you have practiced something, 2 months later so much new things you're learning, you forget all these things, so there will be no point. Maintain a diary and be hopeful, and keep take care of your health and all that. Now these are the general things I want to tell you about dynamics. If you let's see if we got any questions. Okay, so we don't have any questions on this. That's cool. Now so I all the best for your preparations, and we'll see you again next Friday with a new topic on BYJU'S FB Live. Now please go through our YouTube channel. There are a bunch of really interesting videos, and download our app and try to see the videos, and I'm sure you'd find them fascinating, because the way we're taking it, I don't think anybody anywhere is doing it in that way, right? All the best.